Good afternoon. Next topic is arithmetico. Arithmetico. Arithmetico geometric series. Right? पहले हम लिख लेंगे definition. Actually, it is the combination of AP and GP series. So a sequence, each term of which is obtained by multiplying the corresponding terms of an AP arithmetic progression and GP geometric progression is called AG sequence. Is called AG arithmetico geometric sequence. AG sequence. Right? See, the general or standard notation for this sequence will be A plus D into R, A plus 2D into R square. Right? Here this A means A into 1. This A plus D into R means A plus D from AP, R from GP. This part from AP, this part from GP. So we are multiplying corresponding terms of AP and GP sequence to obtain AG sequence. So here the AP becomes A plus D, A plus 2D, right? And GP becomes 1 R square onwards, right? So here you see the another term of AP here is AN will be A plus N minus 1 into D, and another term of this GP is A into R raised to power N minus 1, and here of course A is equal to 1, so it becomes R raised to power N minus 1 because we have assumed GP with the first term as 1, right? It means the another term of AG sequence, therefore another term of AG sequence will be A plus N minus 1 into D into R raised to power N minus 1. AP part, GP part. Right? Or I should say an AG series. Series means we are connecting terms by the sign of plus minus or both. An AG series with n terms will be a plus d into r right plus a plus 2d into r square, and here a plus n minus 1 into d into r raised to power n minus 1. This becomes series with n terms, AG series with n terms, right? Here we have some important points to be kept in mind. In the case r is equal to 1, then this AG series will be converted into AP series of n terms. We can check when r is 1, it becomes a plus d, a plus 2d onwards. I have replaced r by 1. So the AG series gets converted into AP series in the case r is equal to 1 in this series report, right? Similarly, when we put d is equal to 0, that common difference is equal to 0 in the AG series, when d is equal to 0, it becomes a plus ar plus ar square. D is 0, a plus ar plus ar square. I am putting d is equal to 0. Likewise, it will be a into r raised to power n minus 1. And this is nothing but geometric series. Of n terms. It means the AG series with a combination of corresponding terms of AP and GP series can be easily converted into AP or GP by suitable substitution. Now we move to next subheading of discussion. It is sum of n terms of AG series. Sum, we should write sum to n terms. Sum to n terms of AG series. What is SN? Sum to n terms. It is a plus d into r, a plus 2d into r square. Likewise, it is a plus n minus 1 into d into r raised to power n minus 1. This is AG series with n terms. If I multiplied both sides by r, that stands for common ratio of the geometric progression. It becomes r times Sn. So please keep in mind, when we multiply with r, the resulting term should be written from the under the second term. See, r, it becomes AR. I'm writing A into R. AR here, not here. That will make the subtraction process easier. AR. Right? So plus, this is A plus D, R square into R, it becomes R square. We are writing result here. And when we multiplied this term with R, here comes R raised to power N. So that term should be written here. A plus N minus 1 into D. We can use bar bracket into R raised to power N. Right? It means the preceding term has to be A plus N minus 1 into D into R raised to power N minus 1. Here comes, it is N minus 2. Here comes, it is N minus 1. Here comes N minus 2. Rest is same. Hope it's clear. Now, see, we call it number 1 and we call it number 2. Now we subtract 1 minus 2. When we subtract, Sn will be common, 1 minus R. This is equal to, when we subtract, this A is retained as such, we write it as such, A plus, no, AR minus AR, it will be cancelled. What remains behind? Only DR plus DR. And here A R square will be cancelled. 2dr square minus dr square, it becomes only dr square. 2 n terms, right? 2 n terms minus this last term, this one, because all other terms are getting partially cancelled, but it remains as such. It will be A plus N minus 1 into D into R raised to power N. Right? So therefore Sn, I am supposing R to be not equal to 1. So this becomes A upon 1 minus R. I am dividing both sides by 1 minus R plus dr upon dr 1 minus R square, and here inside comes 1 minus R raised to power N minus 1, and last of all here comes A plus N minus 1 into D into R raised to power N upon 1 minus R. This step needs to be clarified. The second step, let me discuss it separately how it came. You see, actually, see this part. This becomes GP. with first term A and common ratio equal to, or we can start from here also, no problem. From here we can start. It is a dr square. First term as dr and common ratio equal to r. For this segment, the total will be a means dr, a into 1 minus r, common ratio r, raised to power n minus 1. It contains n terms, but excluding this part, it contains n minus 1 terms. So from here to here we have n minus 1 terms. So 1 minus r raised to power n minus 1 upon 1 minus r. So when we divide by 1 minus r both sides, it becomes 1 minus r whole square. So actually for this part we need to apply the formula for sum to n terms of GP, with the first term equal to dr and common ratio equal to small r. From here to here it contains n minus 1 terms. So you should remember this formula as such. So although in solving problems we will avoid using this formula directly, we will apply the process as such. Means writing Sn, then writing r times Sn, then subtracting. That way we shall proceed. Now there is one more sub point of discussion. It is sum to infinity of AG series. Sum to infinity means sum to infinite many terms of an AG series. So what is Sn? We have just discussed Sn is equal to a upon 1 minus r plus dr into 1 minus r raised to power n minus 1 upon 1 minus r whole square minus a, it is a plus n minus 1. Let me erase it. So it is minus, see it was minus, it is this, I move, a plus n minus 1 into d into r raised to power n upon 1 minus r. This was the formula for finding sum to n terms of AG series. Now here, if numerical value of r is less than 1, see, as n goes to infinity, if it contains infinite many terms, then r raised to power n minus 1 or r raised to power n, all these terms will tend to 0. They will be as close to 0 as possible. Right? It means this sum, it does not contain anything of the type r power n minus 1 or r raised to power n. It means this remains as such, a upon 1 minus r plus, now dr upon 1 minus r whole square does not contain dr into 1, it is dr only. It does not contain r raised to power n minus 1 or r raised to power n as coefficient. So this also remains as such. But when I multiply this with the second term, it means this becomes a coefficient of dr and is tending to 0. It means result will also tend to 0. It means the remaining term beyond this will all vanish, will eliminate, right? So this is the ultimate expression. We can write here s infinity also, no problem. It is for AG series. It is for AG series. So how is the content, video, audio going on? You can write your reply. So that I can move to now the working part. Let us move to the application part. See, first problem we take. Sum to n terms of the series. Series is given to us. It is 2 plus 5x plus 8x square 11x cube onwards. Numerical value of x is less than 1. Deduce sum to infinity also. Deduce s infinity. On this part I need to calculate. Deduce s infinity. Deduce s infinity means I need to find Sn. Then from there I need to calculate s infinity. Right? So solving such problems need little common sense also. Means we need to decide which part forms AP and which part forms GP. So the given series is formed by multiplying the corresponding terms of AP. See the AP part, 2, 5, 8, 11, isn't it? With first term 2 and common difference 3, and the GP part is 1 x square, the GP part, x cube we can write. So first step will always be to write the AP and GP component of the given AG series, right? Then you must proceed to write another term. So another term of AG series is another term. It will be A plus, what is A2? A plus n minus 1 into D. D is 3 into R. What is R? R is x raised to power n minus 1. So this is the another term. We can simplify it. It will be 2 plus 3n minus 3 into x raised to power n minus 1. This is 3n minus 1 x raised to power n minus 1. Right? So this is what we have written. Nth term, general term. Right? Now let us proceed to calculate Sn. Sum. So we write all terms as such. It was a two. I've told you during the discussion part of the article also that for calculating sum to n term, we shall be following procedure, not formula. That is little difficult to recall. If you can recall, you can apply formula, so no problem. But following process will be more convenient. So 2 plus 5x plus 8x square plus 11